Hello everyone. This problem has been asked in GATE 2022 and it is of 2 marks. This problem says that if the magnetic field intensity in a conducting region is given by this expression x square I cap plus s square y square j cap plus x square y square z square k cap ampere per meter. The magnetic field intensity is given by this expression and the magnitude of the current density in ampere per meter square at x is equal to 1 meter, y is equal to 2 meter, and z is equal to 1 meter. We have to find that. Okay, that means we have to find the j. We have to find the magnitude of current density. That means so if you want to go through detailed description about this circuital law, you can kindly refer this NPTEL course by Professor Hari Shankar Ramchandran, Department of EE, IIT Madras. And the YouTube link for this lecture is also given here. Now let us have some quick recap about the basics of electromagnetic theory field and basics of this Ampere circular law, and then we will solve the problem. So we study there are three types of orthogonal coordinate system in electromagnetic theory subject, and these are Cartesian coordinate system, cylindrical coordinate system, and a spherical coordinate system. And and for all this coordinate system, the axis has been given here x, y, z, r phi z, and r theta phi. And if you want to write this infinitesimal small distance del L, dl, and a small infinitesimal volume dv, you can write accordingly. Based on this, a small infinitesimal distance dl, we can write for Cartesian coordinate system like this: dx dot x cap plus dy dot y cap plus dz dot z cap, and we can write dv, that is a small infinitesimal volume dx dy dz, and similarly way we can write for cylindrical coordinate system and a spherical coordinate system like this way. Now what is the curl rotation operator? That is delta x delta cross. So if we are having general form like a small infinitesimal distance dl, uh, as represented like h1 d u1 u1 cap plus h2 d u2 u2 cap plus h3 d u3 u3 cap, and the function we have been given like here f u1 u1 cap plus f u2 u2 cap plus f u3 u3 cap. Now suppose you have to find this curl of this vector f, then you have to do the cross multiplication of del cross f, that will come like that: 1 divided by h1 h2 h3, that is the coefficient of this a small infinitesimal distance dl, and inside this determinant you can write like this way. Now if you want to apply this generalized form for curl operator, for like here we have applied for Cartesian coordinate system, then for Cartesian coordinate system here h1 is equal to 1, h2 is equal to 1, and h3 is equal to 1, and we can write dl as dx dot x cap plus dy dot y cap plus dz dot z cap, and if we have written fx x cap plus fy y cap plus fz z cap. So you can write this curl operator, you can write this cross multiplication of del cross f like this way. In this problem is related with Ampere circuital law. We know that if this current carrying conductor having current DC current passing through it I. Then at point P, how we can calculate this magnetic field density. So, or like magnetic field intensity. If you can calculate this magnetic field intensity, then you can also calculate this magnetic field, magnetic field density by multiplying with the permeability of the medium. B is equal to mu naught mu H. So what does this circuital law says? It states that the line integral of magnetic field intensity around any closed path is equal to the direct current penetrate through the path. So it states that means you have to take the line integral of magnetic field intensity around this closed path, and that will equal to the direct current penetrating through the path, means how much amount of current is penetrating through this closed path. So that will you can write in mathematically that line integral of h dot dl is equal to I, the total amount of current is penetrating through this is penetrating through this closed path. Now applying a Stokes theorem by converting this h dot dl into a sphere form, then that will be integral of del cross h dot ds is equal to I, and you can write this I as in the form of current density, that is J dot ds. So on comparing this del cross H dot ds with J dot ds, you will get del cross H is equal to J, and this is the differential form of Ampere's circuital law. And this Ampere's circuital law is valid for a static electric field only, that is for magnetostat. This Ampere's circuital law is valid for a static electrical field only. And if you want to calculate the for time varying electric field, this Ampere's circuital law is not valid. And for that, we apply modified Ampere's circuital law for the time varying electric field. And the modified Ampere's circuital law is del cross H is equal to J plus partial differential of d, that is electric field density. So now let us solve this problem. So here in this problem we are given with h is equal to x square I cap plus x square yj cap plus x square y square z square k cap ampere per meter. We know that j equal to del cross h. Since it is in Cartesian coordinate system, then we will apply this expression as we have seen in the previous slide. So we can write this is equal to determinant of x cap, then partial derivative with respect to x by cap, partial differentiative with respect to by z cap, partial derivative with respect to z axis, and here we will write this coefficient of different axes x square, and for by x square y square, and for z x square y square z square. So just we need to solve this. J current density will be J equal to x cap to x square yz square minus 0 minus y cap to x 0 plus z cap 2x y square minus 0. So finally we will get 2x square yz square x cap minus 2x square y square z square plus 2x square y square. Here y cap will be here z cap. Now we will find with respect to the point current density at point 1, x is equal to 1 meter, y is equal to 2 meter and z is equal to 1 meter. Put all these values. 4 1 y cap plus 2 1 4 z cap. So this will be 4x cap minus 8y cap plus 8z cap. And in this problem we have to find the magnitude of current density at this point. So we will take the magnitude, that will be 4 square plus 8 square plus 8 square 16 plus 64 plus 64 to the 100 whole root. This will give 144 and finally we will get 12 ampere per meter square. So the correct option for this problem is B. That's all. Thank you.